In this video, we're going to see how we can conduct a hypothesis test for two means where the two populations are matched, sometimes called matched pairs. So this question says, listed below are the numbers of words spoken in a day by each member of 8 different randomly selected couples. Complete parts A and B below. So here we have a table or a group for males and then another group for females. And what we need to understand here is that the numbers in the same column for the male and female, those are paired together because this is from the same couple. This man who spoke 16,000 words is paired with this particular woman who spoke 24,000 words. That's important because that's going to help us know what are the appropriate values and formulas to use for this test. So matched pairs. So letter A says use a 0.01 significance level to test the claim that among the couples, males speak fewer words in a day than females. Then it goes on to say in this example, mu d, that means the mean of the differences, is the mean value of the differences, d, for the population of all pairs of data, where each individual difference, d, is defined as the words spoken by the male minus the words spoken by the female. So that's important. We have to remember that the differences are going to be the males minus females. What are the null and alternative hypotheses for this hypothesis test? So remember, H0, the null hypothesis, always has an equal sign in it. That's been true in every video we've done and will be true for every hypothesis test you do of this type. So the equal sign is going to be here in the H0. And the number that's going to go here is 0. Because what we're saying basically in that null hypothesis in simple English is that the words spoken by the males and the females are the same. If you have two populations and their difference is 0, the only way you can get a difference of 0 is if they were the same in the first place. So the null hypothesis symbolically is mu d is equal to 0, and in practical terms it means that the words spoken in the two groups was the same. So now remember, the claim said that the males speak fewer words than the females. Also remember, the way we were supposed to do the difference is we were supposed to take the males and then subtract from that the females. So if the males speak fewer words, thereby the females speak more words, and if we subtract in this order, then that means we would get a number less than 0, right? If you take a smaller number and subtract a bigger number from it, you should get something negative, less than 0. So now we need to find the test statistic. So first let's go ahead and open up our data in Excel by clicking the little blue box in the corner and going open in Excel. So here's our data here for the males and for the females. So the first thing we need to do is we need to figure out the differences. So right here I'm going to make a whole new column called differences. And what we want to do in this column is we want to subtract the numbers in these pairs in the order that they told us to in the question. Remember, they told us that we were supposed to do the males minus the females. So I'm going to start a formula right here by starting an equal sign, and I'm going to go males, clicking on the male number from this first pair, and subtract the females, second number from this pair, and hit enter. So this number here is now telling me what the difference is between the male and the female from this first pair. When I get this negative number, that tells me that the woman spoke more words than the man did. More words to the tune of 8,260 additional words. I want to do that now for every single pair. So to do that, I can just highlight my cursor over this little box in the corner, click it and drag down, and Excel will copy that formula into every single row. So if I go to any particular row here and look at the formula, I can see that it's taking the male minus the female words for that particular row. So this is important now because now what we're going to need to do is use this column right here. Let's go ahead and highlight it. And this is like a new column of data that we're going to use to do our test. So it's almost like we took two populations and condensed them down into one single population of just the differences. And now we're going to do a test the same way we did a test for a single population in prior sections. So what does all that mean? So first we need to find the sample mean. That means the mean of the differences. So usually we call this D bar, or you could call it X bar if you're used to saying X bar, it doesn't matter. So the D bar is going to be the average, the mean of the differences. We find that by going to formulas, more functions, statistical, average, and we're going to take the numbers, just go highlight them from that differences column that we just created. We'll click OK. So the average, the mean of the differences, is a negative 1508.25. So that means on average, the women are speaking 1,500 more words than the men. We also need to find the standard deviation. So we call this SD usually. So that just means the standard deviation of the differences, or you could say standard deviation differences, or however you want to note it. So this one we'd go formulas, more functions, statistical, go all the way down till we see stdev.s. That means standard deviation from a sample. The S is for sample. Click on that. And again, we're going to go highlight the numbers in the differences column and click OK. So now I have the mean of the differences and the standard deviation of the differences. Lastly, I need the size of the sample. For that one, we went formulas, more functions, statistical, count. Same thing, we're going to go highlight the numbers and the differences and click OK. So there were 8 pairs of data here. Now we need the test statistic. Well, the test statistic is still going to be this one, the same one that we used in a prior section. So to find the test statistic, we're going to start a formula with an equal sign. So first was the X bar. In this case, it's a D bar. Anyways, it just means the mean of the sample. So that was this number right here. We're going to subtract from that the mean that's in the hypothesis in our H0 and our H1. Remember though, in this case that was 0. So you can put a minus 0 here if you like, but anything minus 0 is just itself. So it's a little redundant to say that. So you can actually just put the X bar or the D bar in that numerator. Now we're going to divide that by the standard deviation divided by the square root of n. We need to put that fraction in parentheses so we make sure the whole fraction gets captured in the denominator. If you don't put parentheses here, Excel will do the order of operations in the wrong order and you will not get the right answer. So parentheses, standard deviation, divided by the square root, which is SQRT, parentheses, of the sample size, which was this 8, close the parentheses on the square root, close the parentheses on the denominator, hit enter. So here is our test statistic. That was the first thing we were asked for, and we wanted to round that to 2 decimal places. So this is more than 2 decimal places, but we can always adjust that by going to the Home tab at the top and coming here to either increase or decrease the number of decimal places as we see fit. So we're going to decrease this down to 2 decimal places, and we see the test statistic is negative 0.42. Now we need the p-value. So the p-value is going to be found based on if we have a left, right, or two-tailed test. If we have a left-tailed test, we're going to use the tdist function. If we have a right-tailed test, the tdist rt, right function. And if we have a two-tailed test, it'll be tdist 2t. So we know what kind of test we have by looking at our alternative hypothesis. So here, the alternative hypothesis had a less than sign in it. If you have an inequality, you can kind of think of that inequality as being like an arrow. So that looks like an arrow that's pointing to the left. So that tells me I have a left-tailed test here. So for my p-value, I'm going to go to formulas, more functions, statistical, and I'm going to go down until I find that tdist, t.dist right here. For the x in the options they want here, that's going to be the test statistic. So I'm going to click on the test statistic right here. For the degrees of freedom, remember that is n minus 1, the sample size minus 1. So I can click on the sample size and then subtract 1 from it. And for cumulative, we always type true because we do want the whole cumulative area in the whole left tail. We click OK. So the p-value is this number right here, 0.3433, etc. But we only wanted to round to 3 decimal places, so let's adjust that by going to Home and back to this button right here. So 0.343 is the p-value. So now we need to make a conclusion about our claim based on the values that we got. The way we do this is we look at the p-value, which is right here, and we compare that to the significance level, which in this case was right here. The rule is if the p-value is less than the significance level, you will reject H0. If the p-value is more than the significance level, you will fail to reject H0. So in this case, our p-value of 0.343, that's a lot bigger than the significance level of 0.01. So that means we should fail to reject H0. So here, since the p-value is greater than the significance level, we will fail to reject the null hypothesis. Now, what does that mean in practical terms? Well, remember, this was the null hypothesis, and remember we said that this basically meant in English that the men and women are speaking the same number of words. And this second statement in the alternative hypothesis, that was the claim, and that was saying that the men actually speak fewer words than the women. Well, we just decided to fail to reject the null hypothesis. I have no evidence to reject that statement. So as far as I'm concerned, it might be true that the differences between the men and the women are zero, nothing. There is no difference. Well, if we can't reject that, then we haven't shown any support for our other statement, which was that the males speak fewer words. So in this case, there is not sufficient evidence to support the claim that males speak fewer words in a day than females. So now we want to construct a confidence interval that corresponds to this hypothesis test. Just as a note, when you do a confidence interval and a hypothesis test and you're using the same level of significance or the same confidence level throughout, you should be getting the same conclusion. So if you ever feel like you're getting a different conclusion, but you didn't change anything, something went wrong. So let's go ahead and see how we can construct this confidence interval. So just like we did in a prior section, to find a confidence interval, all we need to do is know the sample point estimate. In this case, that's the average from the sample, the D bar. And from that, we're going to subtract and then add the margin of error. So for the lower limit of the confidence interval, we take the point estimate and we subtract the margin of error. And for the upper limit of the confidence interval, we take the point estimate and we add the margin of error. So we already know what the point estimate is. That's the D bar. That's what we had right here. So now we just need to find the margin of error. In this case, Excel does have a function for the margin of error. That's because we are doing a confidence interval essentially for a single mean like we did in a prior section. So in this case, we can go to formulas, more functions, statistical, and we can go to confidence T. The alpha here is something we need to get from the significance level from our question when we did the hypothesis test. So let's go back and look at that. So remember, when we did our hypothesis test in the first place, we had a 0.01 significance level. So here's the rule about how to figure out what level of confidence you would have in a confidence interval based on a hypothesis test. So if your hypothesis was a two-tailed test, then the alpha level you have for the confidence interval is basically the exact same as the significance level from the test. That's because a confidence interval is always two-tailed. There's a lower limit, there's an upper limit, there's two tails on either side. So it's kind of the same, or it's comparable to a two-tailed hypothesis test. So if you have a two-tailed hypothesis test and now you're trying to get a corresponding confidence interval, the alpha for the confidence interval will be the same as the significance level from the test. If your hypothesis test was a one-tailed test, then you have to now adjust for the fact the confidence interval will have two tails, not just one tail. So you'll have to take that alpha value and multiply it by 2. In this case, remember, we had a one-tailed test. This symbol right here told us it was a left-tailed test. So now for the confidence interval, we need to take the significance level and multiply it by 2 to get the alpha. So 0.01 times 2 is 0.02. So our alpha level will be 0.02. The standard deviation we already had, that was right here, so we can just click on that cell and the program will pull in the value in that cell. And the size was the size of the sample, which we also already had. We can click on the size right here. So we say enter or OK. So this is our margin of error. So now to do the confidence interval, remember we have a lower limit and we have an upper limit. The lower limit is going to be d bar, the point estimate, minus the margin of error. So if we start with an equal sign, we're going to do the d bar minus the margin of error. Enter. And for the upper limit, it's the same thing. It's d bar plus the margin of error. So we start with an equal sign, and we do d bar plus margin of error. Going back to the question, this said to round to the nearest integer, so that means no values after the decimal point. So let's go ahead and go to home, and this button right here, whoops, let's go ahead and highlight those, home, this button right here. So here's our integers. So the lower limit is negative 12,259, negative 12,259, and the upper limit is 9,242. 9,242. So now let's see how we can interpret this confidence interval. The question says, what feature of the confidence interval leads to the same conclusion reached in part A? So remember in part A, we said we did not have evidence to support the claim that the men spoke fewer words than the women. In other words, we basically couldn't disprove or find evidence against the statement that the words spoken were the same. Well, why is that represented here? So in the middle of this interval is the mu d. That means the mean of the differences. So what we're looking for is to see if the value of 0 is contained in the confidence interval. And in this case it is. The lower limit is a negative number. The upper limit is a positive number. So 0 is certainly a number between these two values. So basically, any number between these two values, we have to assume that the difference between the males and the females could be in this range. So if 0 is in this range, then we have no reason to believe that the difference could not be 0. And remember, the difference being 0 means that the word spoken was the same between the two groups. So since the confidence interval contains 0, we need to fail to reject the null hypothesis.